We are CMPE-207 Team 1. Our project is Cloud File Transfer and Storage. We have used Amazon EC2 Amazon Web Services for the same. Here you can see the EC2 console. As we see, CMPE-207 Cloud App Server is nothing but our file server that we are hosting on EC2 Ubuntu instances. This is the server through which the client would communicate and send the files. N1 through N5 are nothing but our database servers. We have used MongoDB for the same. They are configured in the replica set configuration to make our system partition tolerant. Here, whenever there would be a network failure, in that case, our servers, only the primary would be active. If there is a network partition for a longer time, all the servers would become secondary, and this is how our server would be more performance scalable. At any given time, it would be possible only for the primary to write data into the database. In MongoDB, we are writing our file. All our files are stored in MongoDB. We also have a MySQL database hosted on cloud, which is used for storing our login credentials for authentication. Here we can see that this is our MySQL database hosted on cloud. Now we would start our server through PuTTY connection. As we can see, our server has already been started. Since our server is waiting for the client, we will now run our client. Since it is a local client, we are using Tomcat for the same. This is our client page. Here we have provided login and authentication to the client. This is one of our defined services. When the client will try to log in, server will authenticate the client against MySQL user credentials. And if the client is authenticated, he will be allowed to do operations like upload and download. If the client is not authenticated, he would have to register and then start the log in and enter his credentials, and would be then able to upload and download files. We would now register a new user. The user has been successfully registered, as we can see. Just an addition, when the client gets connected to the server, we can see the server log as follows. Here we can see that the client has been accepted along with its port number. Now we will log in with the username and password that we just created. The login has been successful. We can see that in our SQL databases, these are the entries that have already been registered and authenticated for using our file upload and download system. This is our latest entry that we just entered, 2017-1. Before uploading, we will show the already existing repository on cloud. These are the 6 objects that are already present on the database. Now we will upload another file from the client. This is our client repository from which we would be selecting this MP3 for the upload. Now we will click on the upload button. As we can see here, the file has been successfully uploaded into the cloud MongoDB server. As we see here, our MP3 file has been transferred to the server. Here this is transferred and completed transfer on 7:17 p.m. Now we will download the file that we recently uploaded. We click on download. We see that the file has been successfully downloaded. Now we will show the folder where the file has been downloaded on the client repository. This is the downloaded folder where all the files that are uploaded are downloaded. Here we can see that our file has been downloaded from MongoDB successfully. After the successful upload and download, we see that our file server hosted on cloud is successfully uploading and downloading all the files required by the client. Earlier, as I had shown that this file has been transferred by the client to the server, now we see that the server has sent the file to the database. Here, earlier there were 6 objects in the database. Now this is the 7th object. Here we see that the MP3 file has been uploaded to the database by the server. And that is why when the client asks for the file download, since the file had been uploaded, it successfully downloaded the file after upload. In order to achieve performance scalability, we have load balanced and auto scaled our server. Here we can see that this is our cloud load balancer, which whenever the load increases, on the server, the load is it is auto balanced between the two instances. Here we can see our auto scaling group. We have used dynamic auto scaling. That is, if the CPU utilization becomes greater than 90%, our server would increase by 1, and that server would be added to the load balancer by default. So when there are two servers that are working, the load would be equally distributed amongst the two servers. So at any given point of time, the server would be working and there would not be any network timeout. Currently there is one, as the CPU utilization is less than 90%. Thus, we have successfully uploaded and downloaded files using cloud server on AWS. Thank you.